Okay, Algebra 2, here we go into the last section of Chapter 2. 2.8 kind of fits with what we've been doing and also introduces something totally new but not super hard. Two variable but inequalities now. Now, inequalities, everybody, exist separately from an equation, and we've been dealing with equations for all of this chapter so far. An equation, of course, being where two things are equal to each other. So in an inequality, it's when we're dealing with two mathematical expressions that are not equal to each other. There are, let's see if we can figure them out here, guys, 5 different inequality symbols in algebra. And as soon as I give you one, if you don't already know what I'm talking about, you're going to figure out 3 more of them really quickly. One of them is the good old less than sign. One of them is the greater than sign. Then there's also less than or equal to. There's greater than or equal to. And then the 5th one that people have a hard time coming up with is actually the word itself. Inequality means not equal to, so that not equals is an inequality sign as well. We don't actually do much with that 5th one, though. These are the main 4 we're going to work on. So, when we go to graph two variable inequalities, there's a main idea that's at work here that I want to make sure everybody gets down. So this is important here, just like when we're graphing an equation. So similar to what we've been doing in this entire chapter so far, we shade. Now that's an important word here. We shade, or we graph, all points on the given coordinate plane that satisfy the given statement. Okay, so we graph the points that work, and then, this is probably worth noting as well, we do not shade, or we do not graph points that do not work. It sounds obvious when you write it down right there. It seems like one of those statements where you go, yeah, why wouldn't anybody get that right there? But it's probably helpful to write that out. We do not shade points that do not work. So, I'm not sure if that makes a whole lot of sense, but I'm going to explain that. I'm going to come back to that idea in each of these examples that we're about to do. Now, with that in mind, guys, that's the only bit of new theory that we need to talk about in section 2.8. Let's work on our first example here. This is one we'll kind of learn by doing. So the directions say to graph each inequality. So back to what we just wrote down, graphing means that we shade all the points that work and we don't shade the points that don't work. So here's the inequality we've been given now. And sorry guys, typing fractions on the smartboard is rough. Y is greater than 2/3 x minus 1. The good news for you guys is that this inequality is in slope-intercept form. Usually we do y is equal to mx plus b for slope-intercept, but this works also when you have an inequality sign like greater than. So I'm going to ask you the same 2 questions. What is the slope of this line? And what is the y-intercept? Since this inequality is solved for y, it's technically in slope-intercept form, and you guys can read me those 2 things directly. The slope is the coefficient of x, which is 2/3, and the y-intercept is the number added at the end, which in this case is -1. Now, if I were to suddenly change this to y equals 2/3 x minus 1, don't do this in your notes, you would know exactly what to do. Y-intercept of -1, slope of up 2 right 3, up 2 right 3, up 2 right 3, and you'd go ahead and you would graph that line. Don't do this yet, guys. I'm going to undo all that. And every point that you have put on this line, of which we located 4, but there's really an infinite number, every one of those points satisfies this statement right here. Like, for example, this is the ordered pair 3, 1. Let me show you what I mean when I say it satisfies. My y coordinate there is 1, and if this was an equation, that would be an equal sign right there. 2/3 times my x coordinate of 3 minus 1. Well, let's see what happens here, guys. 2/3 of 3 is 2. 2 minus 1 is 1. 1 equals 1 is obviously true. Check. So this point satisfies the equation. That's why we graphed it, because that point works. Now, we're going to do something similar here with an inequality, but things are going to change just a little bit. The y-intercept is still the first point that we deal with, but I'm going to do something weird here, guys. I'm going to put an open dot at that point right there, and I am not going to fill it in. Now, this is something I have my students do that other Algebra 2 teachers might not. So if you have a friend in another class, they might be filling in that dot. We're not going to do that, and I'm going to explain to you why right now. That is the ordered pair 0, -1. Now, if that ordered pair satisfies the original inequality right here, then we should shade it in. If it doesn't satisfy that statement, we should leave it empty. Let's find out if it works. I'm going to put the -1 in for y is greater than 2/3 times an x coordinate of 0 minus 1. So let's see if it works or not. -1 is greater than 2/3 times 0 is 0, and 0 minus 1 is -1. So I want you to look at that statement right there and think to yourself, is it true or is it false? -1 is greater than -1. That statement, everybody, is false. -1 is not bigger than itself. It's equal to itself, but not bigger than. So for that reason, because that point doesn't work, I'm going to leave that dot open. But it's still important. It's a boundary. It's on the border between the region here that works and the region that doesn't. So we used our y-intercept. Now I'm going to use my slope of 2/3, just like I did with an equation. Up 2 and right 3, open dot, because guess why? This point won't work either. Up 2, right 3, open dot. Up 2, right 3, open dot. And if you ran out of room or you wanted to be even more thorough, you could have gone down 2 and left 3, open dot. Down 2, left 3, open dot. And now what we have is a whole series of points here that don't satisfy the original inequality, but they're very, very close. So for that reason, we're going to draw a dashed line through all those empty dots right there, open dots right there. And that dashed line means the same thing as the open dots. These points don't quite work, but they're very, very close. So what have we accomplished then? We haven't really shaded anything yet. Well, our goal here is to figure out all the points that work, that satisfy this inequality, and shade them in. And what I need you guys to notice is that this line divided the coordinate plane up into two regions. There's the region up here that is above the line, and then there's this region down here that's below the line. One of those two regions contains an infinite number of points that satisfy this inequality right here. And the other region contains an infinite number of points that don't satisfy that inequality. Our job now is to figure out which one is which. So the way we're going to do that, everybody, I'm going to show you one method and then I'm going to give you a shortcut here, is we're going to choose a test point. And the easiest point in the world to check, everybody, is the origin, right here at the point 0, 0. Now, that point is close to the line, but not quite on it. That means it's either going to work or not work, and we're going to plug 0, 0 in and find out. So I'm looking back at the original statement right here. Y is 0, and I want to know, is that greater than 2/3 times an x coordinate of 0 minus 1? 0 is greater than, and here we go, everybody, 2/3 times 0 is 0. 0 minus 1 is -1. And is 0 greater than -1? Yes, it is. So here's what that tells me. The origin works. And so for that reason, that point gets shaded. And if the origin worked, so does every other point that's on the same side of the line as the origin. That means that it's the upper region up here that contains all of the points that satisfy the original statement. So I shade the entire coordinate plane above the line. Every point, therefore, that is below the line must not work, and so we don't shade below the line. So let's just verify and make sure we got this right. I'm going to clear some space here because I'm running out of room. We saw that the origin worked, but I want to make sure of two other things here. All right, I'm going to pick another spot. I'm going to pick, let's see, this point right over here, guys. And that looks like the ordered pair 0 and then 5, I believe. So I want you guys to ask yourself, is that point shaded or unshaded? That one's in the shaded region. Therefore, should it work or not work when we put it back into the original statement? If it's shaded, it should work. Let's try it. Our y-coordinate there is 5. 5 is greater than 2/3 times an x-coordinate of 0 minus 1. Well, that's the same math I did on the right side before. 2/3 times 0 is 0, minus 1 is -1. 5 is greater than -1. That's a true statement. I'll just put a big T right there, and that makes me feel pretty good, everybody. Every point that you choose in the shaded region should work. And now, just to kind of ram the point home, let me switch to a different color here. Let me go to green. All right, I'm going to pick a point in the unshaded region. I'm going to go right about here, guys. I like to stick with those zeros here. I'm going to go with 0 and then -4 for the y coordinate. So ask yourself two questions. Number one, is this green point shaded or unshaded? This is in the unshaded region. Therefore, should it work or not work when we put it into the original statement? An unshaded point should give us a false statement. Let's make sure. Our y coordinate there is -4, and I want to know, is -4 greater than 2/3 times 0 minus 1? Well, let's find out. -4 is greater than 2/3 times 0 is 0, minus 1 is -1. -4 is greater than -1? No, it's not. That statement right there is false. And that actually makes me feel pretty good about my answer because I chose a point in the unshaded region and got a false statement. So every point that's in the shaded region should give you a true statement. Every point in the unshaded region should give you a false statement. Okay, so that's how that one works. So we end up then shading half of the coordinate plane in every one of these problems. All right, let's try another one right here. I'll switch back to blue here. All right, y is less than or equal to, this is different now, 1 minus 2x. Okay, we're still solved for y, so I can ask you the same two questions. What is our slope and what is our y-intercept? And I hope you noticed this right off the bat. I made this one a little bit tougher because I gave you the two terms out of order. The constant, which normally comes at the end, is now out in front. So hopefully you're not fooled by that. M, the slope, is the coefficient of x. That's -2 here. And the y-intercept, the number that gets added, usually at the end, but not always, is a +1. So we're going to graph this by first looking at our y-intercept, which is 1. And on the last problem, I told you guys to put an open dot there because that point didn't work. Let's find out now. This is the ordered pair 0, 1. Let's see if it works or not. Our y-coordinate is 1. Is less than or equal to 1 minus 2 times 0. Let's find out if that statement is true or false. 2 times 0 is 0, and 1 minus 0 is 1. So we get 1 is less than or equal to 1. True or false? Because of the or equals to on the bottom, that statement right there is true. And that is why for this problem, we have to shade in that dot. Because of the or equals to on that inequality symbol, the border points work in this case. Unlike the last problem where it wasn't greater than or equal to, it was just greater than, that gave you a border point here that was a false statement. -1 was not greater than -1. But in the problem we're working on right now, because it's less than or equal to, 1 is less than or equal to 1 is a true statement, and so we color those dots in. All right, now we're ready to use the slope. -2, which of course is -2 over 1. That means we're going down 2, right 1. And guys, anytime you did one solid dot, all your dots are going to be solid. So I just keep going down 2, right 1. I could go up 2 and left 1 at some point if I wanted to. And with closed dots, this is what we've been doing lately. We're going to go back and draw, oh, that's not very straight. We're going to draw a solid line that goes through all of those collinear points. So the shortcut here, guys, is this. When we're dealing with an or equals to, in this case, less than or equal to, closed dots and a solid line. Back to the previous problem, when the symbol you're dealing with for your inequality, when your inequality symbol is not or equal to, this one was just greater than, we did open dots and we did a dashed line. Okay, we still have to decide whether we're shading here above or below this line. So in this case, let's pick another ordered pair. And again, guys, I'll stick with what I said. The origin, which is right there, is always the easiest point to work with. Let's find out if the origin works or not. So when we test 0, 0, here we go. Our y-coordinate is 0, is less than or equal to 1 minus 2 times 0. What's that going to do for us? 0 is less than or equal to 2 times 0 is 0. 1 minus 0 is 1. That statement, 0 is less than or equal to 1, is true. That tells me what I think we need to know, guys. We're going to shade the side of this line with the origin, which is this whole bottom left region here. If the origin worked, it stands to reason that every other point on that side of the line would work. And I think this time I'm going to test just one random point here. I'm going to go, I don't know, right over here somewhere, guys, and I think that is the ordered pair of 7, 4. That one, okay, is it shaded or unshaded? Unshaded. And should it work or not work then? It should not work. Let's find out what happens when we plug these numbers in. We're putting a 4 in for y is less than or equal to 1 minus 2 times an x value of 7. Let's check it out. 4 is less than or equal to 2 times 7 is 14. 1 minus 14 is negative 13. And here's our statement now. 4 is less than or equal to negative 13. That pretty clearly is a false statement. Okay, so I feel good there, guys. I chose a point that was not shaded and ended up with a false statement. Okay, I feel pretty good about that one working out. If you really wanted to be thorough, you could choose one more point here somewhere in the shaded region and test it, but I think you're getting the point, the hang of this. Now, I'm going to go ahead, and if I was live with you guys, I'd walk you through this a little bit more, but I want to do... I'll go ahead and give you a little shortcut right here, guys, to save you a little bit of time. When an equation is, when an inequality is in slope-intercept form, greater than always means one thing in terms of shading, and less than always means another. We're talking, let me go back to this first one, about y-coordinates that are greater than everything on the line. Greater than always means you are going to shade above your line. Notice we drew our line here and we shaded up above. That's because of the greater than. In the second example, we ended up with a less than. Anytime you have a less than symbol, that means that you're going to shade down below your line. And that's what happened in example B. So let's keep that in mind. Okay, example C is a little bit tricky here, and you'll probably see why right away. Unlike A and B, this one was not given to you in slope-intercept form. This one was given to you in standard form, and so we're going to use the same method we've been using for graphing out of standard forms so far. We're going to solve this inequality for y. That'll put it in slope-intercept form, and we can read the slope and the y-intercept pretty quickly then. However, there's one little quirk, everybody, of solving inequalities that I'm certain you learned 2 years ago in Algebra 1, but you may have forgotten. So we'll get to that in just a second. Okay, we're going to try to get y by itself. The first thing we're going to do is subtract an x from both sides, and that will give us negative 2y is less than or equal to, and that's written best as a negative x minus 10. To get y by itself now, we need to divide out its coefficient of negative 2. And right now, this is the quirky thing here, guys. When you divide, or multiply, but in our case, it's almost always divide. When you divide both sides of an inequality by a negative number, like in this case, negative 2, your inequality sign flips, meaning on the next line, instead of less than or equal to, it's now going to become greater than or equal to. That only happens when you multiply or divide both sides of an inequality by a negative number. If this had been a positive 2, we would not be flipping the sign right now. Now, the good news is, if you check your answer here the way I've shown you to do on the last two problems, you're going to know if you made this mistake or not. So you guys will see in a second that we've got this right. Okay, negative 2's cancel. We get y is greater than or equal to negative x divided by negative 2. Well, negative divided by negative is positive. Don't forget there's a 1 right here, so we're going to write that as a positive 1/2 x. And then negative 10 divided by negative 2 is plus 5. So I'm going to box that up. There's the original inequality now, but solved for y, meaning it's in slope-intercept form. So what is the slope of that line? That should be a positive 1/2. And the y-intercept of that line, that is a positive 5. So time to graph this thing, and then we'll test it and see if we're right. Our y-intercept is 5, which is right up here. And now ask yourself, do I fill in that dot or not? Well, if we go back and look, because there's an or equals to sign right here, that means we fill that dot in. That's a solid dot. And we believe our slope is 1/2. So up 1, 2 to the right, and a solid dot. Up 1 and 2 to the right. Could have gone down 1, left 2, down 1, left 2, and that's good enough. Solid dots mean that we're going to make a solid line going through those points. Okay, arrows on both ends. And again now, we either shade above the line or below the line. Now, using the shortcut that I just taught you, we look right here, not up there, guys. Don't look at the original statement. That's no help. Look at the one in slope-intercept. When y is greater than, we're going to shade above our line. So that means that we should be shading every single point up here that works, and then leaving this whole lower right region blank. So I feel pretty good about my answer, but I've been doing this for a long time. You guys might not feel great about your answer. So what you really should get in the habit of doing is choosing 2 points here, and one that's in the shaded region, one that's in the unshaded region, and making sure they both give you what you want to see. I'm going to choose this point right up here, which looks to me like it is -9 and then +6. So let me write that down here. -9, 6, and let's find out. Now, to make sure I didn't make any algebra mistakes, I'm actually going to test this point with the original inequality right here that was written in standard form. That'll let me know if I made a mistake in the algebra up here, most notably in flipping the sign. So I'm checking that right here, guys. So my x-coordinate is -9 minus 2 times a y-coordinate of 6 is less than or equal to -10. Now again, because that point is shaded, this should work out for us. Okay, we should end up with a true statement. Let's find out. -2 times 6 is -12, so I get sorry about that. Nope. I get -9. All right, and then -12 is less than or equal to -10. Let's put those together. That's a -21 is less than or equal to -10. True or false? That is a true statement. And because this point is shaded, I'm going to put a check by that. That's exactly what I wanted to see. A point that's in the shaded region should give you a true statement every time. And now let's pick a point that's unshaded. And of course, no point is easier to test than the origin itself. So this is going to be my point I'm choosing here that should not work. Let's try it. 0, 0. And again, I'm going back into the original statement up here at the top, where x is 0 minus 2 times a y-coordinate of 0 should not be less than or equal to -10. Again, I'm expecting a false statement. Let's see what happens here. This is actually a really nice thing about standard form. 2 times your y-coordinate is going to be 0. The x-coordinate is 0. 0 minus 0. With standard form, the left side pretty much always becomes 0. Is less than or equal to -10. So now ask yourself, let's look at that again. 0 is less than or equal to -10? Nope. That one there is a false statement because 0 is greater than -10. But that false statement makes me feel good. I chose a point that was not shaded, and I ended up with a false statement. So this is 2 things that kind of tell me that we did this problem here correctly. All right, so hopefully we're getting the hang of this, and hopefully we're seeing that this isn't really as scary as you might have thought at first. A couple little quirky examples I want to throw at you right here. D and E we're going to do should be super simple if we learned what we were supposed to learn from earlier in the chapter. Case in point, here we go. Y is less than -3. What sticks out at you as funny about this inequality? hopefully you'll notice there is no x. And just like with equations, when there is no x, that means that we are dealing with a horizontal line in this case, and that this number here, -3, is your y-intercept. So here we go, horizontal line with a y-intercept of -3. I'm going 3 units down and I'm putting an open dot at first. Now I think, is it an open dot or a closed dot? We look at the inequality symbol, and because there's no bar underneath it, it's not less than or equal to, because it's just less than, that means we leave this as an open dot. And we draw the one and only horizontal line that goes through that open dot. Because it's just less than, this is going to be a dashed line, horizontal now, going through that open dot. And we put arrows at the end, and there's our line. But again, because it's an inequality, we have to shade. We either have to shade above this line or below this line, and we can use the same shortcut we've been doing. A less than symbol, everybody, means that we are going to shade below the line. So we're going to shade everything here below that and leave everything above it blank. This is a really easy one to test. If I were to choose a point maybe right over here, guys, I think I've got that as 5, and then what, -5, I think. Here we go. When I go to plug that in here, there's no place to put the x-coordinate, so forget it. But the y-coordinate is -5. So -5 is less than -3. True or false statement? That's a true statement, which makes sense because this point is shaded. And if I chose anywhere else above this line, like, oh, I don't know, this point right over here, which I think is -4, +6, well, let's check it here again. My y-coordinate there is 6. 6 is less than -3. True or false statement? That one is false, which makes me feel good because this point was in the unshaded region. So what have we done? We've shaded every single point on the coordinate plane with a y-coordinate less than -3. All right, and the other weird one I have for you now, you probably could have guessed what was coming next, x is greater than or equal to 2. What's weird about this inequality? It has no y, and that means that we are dealing now with a vertical line, and that this number here, 2, is our x-intercept, which we call a, but that's not really important. So on the x-axis, we go 2 units to the right, and I always start with an open dot, and now I think, okay, do I shade in that dot or leave it empty? With greater than or equal to, we shade that in and we make a solid dot out of that. Now, there's only one vertical line that passes through that x-intercept, and this one is going to be a solid line because, again, the same reasoning here, because it was greater than or equal to. So there's our line. Now, right now, we've just graphed x is equal to 2. We need to shade half of this. And in the last 4 problems, I've asked you guys to think about above and below. If it was a greater than sign, that meant that we shaded above your line. If it was a less than sign, that means that we shade below the line. So in this one, it's greater than or equal to, so that must mean that we shade above, except there is no above right here, guys. This is a vertical line, and vertical lines are the one case where you cannot think of above and below because there is no above and below. There's only right and left. So let's kind of think about this. Above, everybody, was kind of in the positive y direction. What we want to do here, because we have a greater than sign, is shade in the positive x direction. And the positive x direction is out here to the right. Okay, so right next to the above, I'm going to put a right there. If it were a less than symbol, less than means we would shade lower x values, and lower x values are over here on the left. So these two cases you just need to consider if you're dealing with a vertical line. So in this case, I believe we're going to be shading the right-hand side of this graph. So I'll go ahead and shade it, but once again, we're not going to leave anything up to chance. We're going to test 2 points and make sure they both work. I'm going to pick, I don't know, this point right over here, which is 1, 2, 3, 4, 5. Looks like the ordered pair, 6, -2. Let's test it. In for x, I'm going to put 6. 6 is greater than or equal to 2. True or false? That one's true. So I think we're in good shape. For my point that should not work, I'm going to pick this guy right here. That looks like 0, -4. So in for x now, we're putting 0. 0 is greater than or equal to 2? I think not. That statement is false, but that's good because I chose a point in the unshaded region, so I should get a false statement. So those last two examples are going to show you how you should handle horizontal and vertical lines. And now, everybody, what I'm going to show you next is going to make you freak out a little bit. This is going to see how well you've learned everything we've done so far in this chapter. Yeah, you can graph inequalities that deal with absolute value. But I'm really hoping what we've shown you here today is that graphing linear absolute value statements is really no different than graphing equations. We just have to think about a solid or a dashed line, and we have to think about shading above or below. So hopefully you guys have watched and done everything you needed to do with 2.7. You would know how to graph this if it were an equal sign. We have here y is greater than or equal to the absolute value of x plus 2 minus 5. So what I'm hoping you guys can tell me is what impact all of these things have. The minus 5 at the end means that we're moving our normal parent graph down 5 units. The plus 2 in the absolute value means that we are moving left 2 units. And so when you put those two things together, that tells you that the vertex of this absolute value v, let's see guys, left 2 is an x-coordinate of -2, down 5 is a y-coordinate of -5. So the vertex of this absolute value graph should be at the ordered pair -2, -5. I'm going to start with an open dot, and now I'm going to ask you guys, should we shade it or not shade it? Well, I'm hoping you've guessed already. With greater than right here, we leave it open. Okay, so that's where we're at that point. Wouldn't be a terrible idea to test that point right now, guys. -2, -5. Let's see if we've got that right up here. The y-coordinate is -5, is greater than the absolute value of 0. Nope, I'm sorry. That should be, no, I lost the whole thing. -5 is greater than the absolute value of -2 plus 2 minus 5. Well, -2 plus 2 is 0. The absolute value of that is 0, and 0 minus 5 is -5. So we get -5 is greater than -5. Now that's a false statement, but the fact that we got the same number on both sides, that tells me that we got the vertex correct. So I feel pretty good about that. Now, the only other thing really to learn about this absolute value graph, we talked about in 2.7 how the value of A determines what direction your V opens and also what the slopes of the rays are. Now, if A were negative, then this graph would open down. But since A, it looks like there is no A there, guys, and we know that's not right, but our A value is 1. Okay, you could put a 1 right there if you wanted. So that tells you two important things. First of all, this absolute value V opens upward. Second of all, the slopes of your two rays are going to be plus and minus whatever the value of A is, which in this case is 1. So we're going to be drawing a V that opens up with rays with a slope of +1 and -1. So +1 means up 1, right 1, open dot. Up 1, right 1, open dot. Up 1, right 1, open dot. And that's probably good. Dashed line going through those points, everybody, and it goes on forever. The other half of this has a slope of -1. Up 1, left 1, open dot. Up 1, left 1, open dot. Up 1, left 1, open dot. Okay, and a dashed line to complete the left side of this graph is going to look something like that. And the only thing left to worry about, because this was an inequality, the only thing left to worry about is our shading. And with greater than, as we've been talking about before, greater than means that we shade above. So I'm going to shade everything above the graph that we just came up with right here, which kind of looks like we're shading inside the V, and we leave everything below unshaded. Okay, now the proof is in the pudding, everybody. Let's find out if we got this right or not. I'm going to check the origin. 0, 0, which is shaded. That means it should work. Let's try it. 0, 0 should give us a true statement back in the original. 0 for our y-coordinate should be greater than absolute value of 0 plus 2 minus 5. Okay, let's see what that does for us. 0 is greater than. 0 plus 2 is 2. The absolute value of 2 is 2, and 2 minus 5 is negative 3. So we end up with a statement 0 is greater than negative 3. True or false? True. And because that point is in the shaded region, I feel good about that. That's what I expected to see. Now let's pick a point that's not shaded. I'm going to go over here somewhere, guys, and I'm going to go with the ordered pair 8, 0. Let's see what happens when we plug that in. Okay, our y-coordinate is 0, is greater than the absolute value of 8 plus 2 minus 5. Okay, let's try that one out. 8 plus 2 is 10. The absolute value of 10 is 10, and 10 minus 5 is 5. 0 is greater than 5. No, it's not. That's a false statement. But because that point that I chose was not in the shaded region, that tells me that my answer is most likely correct. So I picked a point that was shaded, and it worked. I picked a point that was unshaded, and it didn't work. That's what we're accomplishing here in section 2.8. Now, of course, there's an infinite number of points that work. There's an infinite number of points that don't work. We were just testing one of each in order to make sure our answer was most likely correct. Okay, one more for you guys, and then we're done with this section. This is really the same as the problem we just did, just written in a harder way here. All right, y is greater than or equal to 3 minus 1/2 times the absolute value of x minus 1. All right, everybody, so first thing we're going to try to do, we're going to try to figure out the vertex. Our h value is the number being subtracted from x. That's a positive 1. Our k value, the y-coordinate, is the number that gets added or subtracted usually at the end of this whole thing, but that's what this 3 out here is. That's a positive 3, so our vertex is right there at the ordered pair 1, 3. Oh, and I guess I gave it away. I should have written that as an open dot and then thought about it, but because this one is greater than or equal to, we should be filling that in. So let's test this ordered pair, guys. 1, 3. Let's make sure that it's correct. You'll see right away if this is your vertex or not. Okay, in for y, we're going to put 3 is greater than or equal to 3 minus 1/2 times the absolute value of our x-coordinate is 1. So that's 1 minus 1. Now, guys, notice the first thing I'm going to do here to simplify is 1 minus 1. When that number inside the absolute value is 0, that tells you that you're on the right track and you found the vertex correctly. So 1 minus 1 is 0. The absolute value of 0 is 0. 0 times 1/2 is 0. 3 minus 0 is 3. So we get 3 is greater than or equal to 3. That's a true statement because of the or equals to, but more importantly because the numbers on the left and the right were the same. In this case, they're both 3. Yeah, that tells us that we're dealing with our vertex. Good. So we found the vertex. 2 more questions now. What direction does this particular vertex or this particular absolute value v graph open? Up or down? Well, that depends on the sign of your a value, and a is the coefficient of the absolute value. A in this case is negative 1/2. Because it's negative, that tells us that this v opens downward. So it's not going to be a graph that looks like this. That's one that opens up. This is going to be a graph that looks like this, opening downward. The last thing we need to consider, though, what are the slopes of the two rays? And the slopes of your rays are always the positive and negative a values that we just said was 1/2. So a plus and minus 1/2, those are the slopes of our rays. So let me do the negative slope first. Down 1 and right 2 from the vertex gets me right here. Solid dot for the same reason as the last one. Down 1, right 2, down 1, right 2, and that's pretty good. Going the other way now, remembering that this opens down, I'm going to go down 1, left 2, down 1, left 2, down 1, left 2, and all right. That's enough points right there. Because of the or equals to, we're going to draw solid rays here on both the left and on the right. Okay, so that's what our graph looks like so far, and the last thing we have to do is shade. Y is greater than or equal to, that means that we're going to shade above. Greater than is always above, less than is always below. Let's test 2 points. Make sure we got this right. I'm going to go with, how about something like this? I'm going to pick this point right over here, which is -3, +3. And let's see what that one does for us. -3, 3, and here we go. All right, guys, our y coordinate is 3. That should be greater than or equal to 3 minus 1/2 times the absolute value of. Our x value is -3 minus 1. Okay, a little tougher here. Let's see what we got. -3 minus 1 is -4. The absolute value of -4 is 4. Half of 4 is 2, and 3 minus 2 is 1. So we get 3 is greater than or equal to 1. And that statement is true. And since we're in the shaded region, that's what I was expecting to see. And now let's pick an unshaded point. Always use the origin if you can, everybody. 0, 0. And let's find out what happens here. 0, 0. Okay, we're putting a 0 in for y is greater than or equal to 3 minus 1/2 times the absolute value of an x-coordinate of 0 minus 1. Okay, didn't leave myself a lot of room here. Let's see what we can do. 0 minus 1 is -1. The absolute value of -1 is +1. +1 times 1/2 is 1/2, and 3 minus 1/2 is 2.5. So we get 0 is greater than or equal to 2.5. And that statement is false, which makes me feel good because I chose an unshaded point right there. So I was expecting a false statement, and that's what we got. All right, guys, that's a wrap on everything from section 2.8. So let's give that homework a try, see how you do, and good luck, everybody.